Okay, for empirical and molecular formula. Okay, when we say molecular formula, the subscript in the formula actually represents the actual number of atoms, okay, in the element, of each element in the compound. This, say for example, you have hydrogen peroxide, so the molecular formula is H2O2. This is actually the true or the actual molecular formula of hydrogen peroxide. When it comes to empirical formula, this shows the simplest or integer ratio of the atoms in a compound. So empirical formula is also known as parang this is the reduced form. Okay? So when it comes to the empirical formula of hydrogen peroxide na kanina ay H2O2, it will then become HO. Kasi na-reduce na yung mga na-reduce na ang mga subscript. Okay? So since we have two subscript there, hydrogen 2 will be reduced to 2 kasi ang common denominator nitong dalawang subscript ay 2. Okay, that's why na-reduce siya ng HO na lang. Okay, ulitin natin. Molecular is the actual formula. It contains the actual number of atoms, while as empirical is just the reduced form wherein the subscript has been reduced into its lowest term. Okay, so example, we have formaldehyde. The molecular formula of formaldehyde is CH2O. Okay, so as you could see, yung ating mga subscript could no longer be reduced kasi nga wala naman silang common denominator. For carbon 1, hydrogen 2, oxygen 1. So walang common denominator. So therefore, the empirical formula is also CH2O. Okay, while as for acetic acid, it is C2H4O2. Okay, so C2H4O2, merong common denominator itong mga subscript na 2, 4, 2. At that is, ang common denominator nila ay 2. Okay, so the carbon could be reduced to 2. That's why it became 2. It became C na lang. Okay, and then the 4 hydrogen will be reduced into into H2 kasi pwede i-divide siya ng 2. And the oxygen could be reduced into 1. Okay? Kasi nga ang common denominator nila ay 2. Okay? When in terms sa glucose naman, C6H12O6, so the common denominator of these subscripts is 6. So carbon will be reduced to 1, hydrogen will be reduced to 2, and oxygen will be reduced to 1. Okay? Kasi nga ang common denominator nila ay 6. So, sum it up, the empirical formula of these three examples are the same, CH2O, kasi nga nakita natin doon sa computation kanina. But their molecular formula or their actual formula are different from each other because they are different compounds. Okay? So ulitin natin, molecular is the actual formula and the empirical is actually the reduced one. When in terms of problem solving, so may step-by-step process tayo dito. Okay? So let's have the example. Mercury forms compound with chlorine. So meron daw sample or compound na ang laman lang niya ay mercury at chlorine. And the composition is 73.9% mercury and 26.1 chlorine by mass. So pinapahanap what is the empirical formula. So steps could be, you have to convert first the mass, the percentage into mass. So percent into mass, anong gagawin natin dito? Mag-a-assume tayo. Assume 100 grams. Kasi nga, wala naman nakalagay dito na mass nung ating compound. Kaya kapag walang mass na dineclare, of course, you could have the assumption. Okay? Ang pinaka the best na pwedeng i-assume natin ay 100 grams para numerically equal yung mass dun sa percent composition. Okay? And then we also have the next step is mass to mole, wherein we have to use the formula number of moles is equal to mass, divide this by the atomic weight. Okay, atomic weight per element kasi pinag-usapan natin dito. So i-recall lang natin yung triangle natin. We remember that here is the moles or N. It could be computed by having the mass divide this by the molecular weight. But since we are talking about elements here, the molecular weight could be changed into atomic weight. Okay, so atomic weight yan. Ganun pa rin. So number of moles is equal to mass over atomic weight. And then the next step is the ratio wherein kung ano yung mga values na makukuha mo dito sa step number 2, titignan mo yung smallest mole value and divide each individual mole value with this smallest one para yun yung ratio niya. And the last is to find the empirical formula wherein you have to use the ratio as a subscript, whole number ratio as a subscript. Okay? So going back to the problem, mercury is 73.9% and 21.6% is chlorine. So ito yan. Mercury is 73.9% and chlorine is 26.1%. So step 1, you have to use this percent composition of element to compute for the mass. If there's no mass given for the total compound, you have to assume that the compound is weighs 100 grams para numerically equal. So with the assumption, so kailangan nating may assumption, 100 grams of sample, the mass for the mercury therefore is 73.9% times 100 grams per 100%. Okay? So titignan natin kung ilan yung contribution ng mercury dun sa 100 grams kung ito ay 73.9%. Then of course, the 100 will be cancelled, the percent will be cancelled, leaving you with the 73.9 grams this time. So numerically equal yung percent at saka yung mass if the assumption is 100 grams. Then for chlorine, of course, 26.1% multiplied to 100 grams per 100%. So percent will be cancelled. 100 will be cancelled. You are left with grams. So that is 26.1 grams. Okay, now that you have the mass for step number 2. Step number 2, you have to get the number of moles. Okay, moles is the mass from step number 1, divide this by atomic weight. Saan kukunin yung atomic weight? Sa periodic table. Remember, atomic weight, not the atomic number. Atomic weight. Okay, so mercury is 73.9 grams. Divide this by 200.6 grams per mole. Okay, so that would be equivalent to 0.37 moles. So, kunin lang natin yung calculator, i-key in natin itong mga ito. Okay, and of course, the grams will be cancelled, leaving us with a unit of mole. Okay, so, ang mole kasi is mass over atomic weight. Ang unit ng mass ay grams, ang unit ng atomic weight ay gram per mole. Okay, and of course, grams will be cancelled, leaving us mole to be on the numerator side. Kaya ang unit natin dito sa step number 2 ay moles. For chlorine, you have 26.1 grams. Divide this by the atomic weight derived from your periodic table, 35.45 grams per mole. Grams will be cancelled. Key in your calculator, so you're going to have 0.74 moles. Okay, now that you have the mole, next step is step number 3. You have to compute for the ratio wherein the denominator or the divisor will be the lowest mole. So, balik tayo sa step number 2. Meron tayong dalawang value ng mole. Hanapin natin yung pinakamaliit and value is 0.37. So, itong lowest value na to or lower value na to, ito ang magiging divisor natin. So, that would be the divisor since the value is smaller than the other one. Okay, so for the ratio of mercury, so still yung kanyang mole, mercury is 0.37. Divide this by the lower value, lower ratio, which is 0.37 din. Siya rin yung lower. Ito yung actual niya, mole, divide this by the lowest value. So that is 1. Pagdating kay chlorine, ito yung actual niya, 0.74. Divide this by the lowest value or lower value from step number 2, and that would be 2. Okay? This ratio from step number 3 will then be used as the subscript. So, ulitin natin. Okay? So, mercury will have a ratio of 1 and chlorine will have a ratio of 2. Say for example, ang ating ratio ay 1.99. So, pwede yan na i-round off na 2. 1.95, pwede yun na 2. Okay? Pero kung say for example, ang ating ratio ay 1.5, of course, you have to multiply this by 2 kasi medyo malayo na yan. Hindi na yan pwedeng i-round up to 2. So, this would be 3. Okay? Just in case na merong mga hindi near to a whole number. Okay? But if it's near to the whole number, say for example, 4.1, then that could be 4. 5.98, so that could be 6. Okay? That's for the ratio. And then using that ratio, sabi natin sa step 4, that whole number ratio will then be used as a subscript. So kanina, Hg is 1 and Cl2 is, chlorine is 2. So therefore, that would be the subscript for each individual element. Okay? So, but since ang ating rule ay kung ang subscript ay 1, if the subscript is just 1, it could be omitted. Therefore, our empirical formula is HgCl2 only. Okay? Another problem, another example. So here, a compound was found to be 85.69% carbon and the remaining percentage is hydrogen. So you have to find the empirical formula, and given that the molecular weight of the compound was 55.9 grams per mole, you also have to find the molecular formula. So dalawa yung pinapahanap dito. Okay? Isang empirical formula at saka isang molecular formula. Okay? Pero ang pinagkaiba dito sa problem 1 and problem 2, merong binigay na molecular formula kasi gagamitin yan sa paghanap ng molecular weight para sa paghanap ng molecular formula. Sa steps, parang kanina lang din pero may mga nadagdag lang. So still pa rin, first step is mass, percent to mass with an assumption of 100 grams kung walang dineclare na grams. Second step is mass to mole using the formula mole is equal to mass over atomic weight. Then the ratio by dividing each moles derived from step number 2 by the smallest mole ratio. Then step number 4, you have to use the ratio as a subscript for the empirical formula. Okay. Ang bago dito is you have step number 5, which is you have to compute for the coefficient. And that would be equivalent to the molecular weight, which should be given in the problem. Divide this by the empirical formula weight. So, kukomputin natin yung empirical formula weight na makukuha natin dito sa step number 4. Tapos, yun ang gagamitin natin dito sa step number 5. Together with dun sa given na molecular weight dun sa problem. And of course, from that coefficient, you can then use that coefficient to multiply to the subscript that could be found in the empirical formula. So multiply the coefficient to each subscript so that you could get the molecular formula. So may added 2 steps lang dito for the computation of molecular weight. Okay. So going back to the problem, so 85.9 grams, so 85.69% rather of carbon and the remaining is hydrogen. So for this case, hindi niya sinabi kung ilan yung remaining. But we could of course compute for that. If the compound is composed of only 2 elements like carbon and hydrogen, at sinabi na 85.69% ang carbon at remaining ay hydrogen, okay, malalaman natin by subtracting i-minus lang natin yung 85.69% dun sa 100. Kasi alam naman natin that kung ang content lang ng compound ay carbon at hydrogen, of course, ang composition niyan ay magiging 100%. So kung alam natin yan, carbon na yan to be 85.69, then you just have to subtract that percent of carbon to 100% to get the percent hydrogen. And that would be hydrogen. The remaining percent for hydrogen is 100% minus 85.69%. and that would be 14.32%. So if you're going to add the percentage for carbon and hydrogen, dapat mag-equivalent sila ng 100%. Another given is the molecular weight, which is 55.9 grams per mole. Gagamitin natin ito sa step number 5. Okay? Okay, so step number 1. Sabi natin sa step number 1 is from percent to mass. From percent to mass, pero walang binigay na mass, kaya ulitin natin, you have to assume 100 grams of sample. And from there, carbon could be computed by having the percent 85.69% multiplied to 100 grams per 100%. So 100 will be cancelled kasi 1 lang yan. So percent will be cancelled, leaving us with 85.69 grams of carbon. For hydrogen, na-compute natin yung remaining to be 14.32% multiplied to 100 grams per 100%. The percent will be cancelled, hundreds will be cancelled, leaving us with numerically equal 14.32 grams of hydrogen. Now that we have the mass, we move to step number 2, wherein we compute for the number of moles with the use of the mass from step number 1 and the moles, atomic weight rather, from the periodic table. Moles could then be computed by having mass divide this by the atomic weight. So the mass of carbon a while ago from step number 1 is 85.69 grams. Divide this by 12 grams per mole derived from your periodic table. Calculate this and we are going to have 7.14 moles. The grams will be cancelled, of course, leaving us with the mole as a unit. For hydrogen, so the hydrogen is 14.32 grams from step number 2. Divide this by 1 gram per mole from your periodic table. The grams will be cancelled, leaving us with 14.32 moles. Now that we have the individual moles, we could then proceed to step number 3, which is finding for the ratio using the lowest mole. Okay, so for this problem, in step number 2, we have 7.14 and 14.32. We have to get the lower value for mole. So the lower value is 7.14, and this one would be our divisor for each element's molar ratio. So for carbon, originally, as computed from step number 2, it has 7.14 moles. But since 7.14 mole is also our divisor, that's the lower value. So we have to divide it by 7.14, and that would be equivalent to 1. For hydrogen, so we had computed from step number 2, 14.32 moles. So we have to divide this by the lower value. So that is 7.14. So therefore, hydrogen will have a ratio of 2. With this, carbon having a ratio of 1 and hydrogen as a ratio of 2, the empirical formula, this ratio will then be using the, that ratio will then be used as a subscript for the composition of empirical formula. So therefore, empirical formula is C1H2. But since a rule is if the subscript is just 1, you have to omit it. So therefore, the final empirical formula is CH2. Okay, moving on to step number 5 for the computation of coefficient. Coefficient is, yung sabi natin kanina, coefficient is equal to the molecular weight divided this by the empirical weight. So we have to compute first for the empirical weight coming from the empirical formula. Empirical formula kanina, sabi natin CH2. So carbon will have 1 and hydrogen will have 2 here. Get your periodic table, multiply this by the atomic weight. So carbon times 12 is 12 grams per mole. And hydrogen is, there are 2 hydrogen multiplied by 1 is equal to 2 grams per mole. Get the total of this. So that would be 14. Therefore, the empirical formula weight is 14 grams per mole because we have empirical formula as CH2. Okay, now for the computation of coefficient, the given molecular weight kanina dun sa problem, 55.9 grams per mole. Divide this by the computed empirical formula, empirical weight, ito yung kanina, the 14 grams per mole. The grams per mole will be cancelled. We are leaving with coefficient of 4. Take note for the coefficient, wala tayong unit. With this coefficient of 4, we should multiply this with the subscript in the empirical formula to get the molecular formula. So molecular formula therefore is a coefficient of 4 be multiplied to the subscript in the empirical formula. So the 4 will be multiplied to 1 in carbon and will be multiplied to 2 in hydrogen. So therefore, the empirical formula of the substance is C4H8. Okay? So 6 steps.